Download this code from codegive.com, link in the description below. Debugging Linux and proxmox kernel panics with Netconsole, a comprehensive guide. Kernel panics are the nightmare scenario for any system administrator. They indicate a critical failure in the kernel, rendering the system unusable and often losing valuable data. While traditional debugging methods like connecting a serial console can be effective, they can be inconvenient, especially on remote or virtualized systems. This is where Netconsole comes to the rescue. Netconsole allows you to redirect kernel log messages, including panic dumps, over the network to a designated server. This enables you to capture critical information during a kernel panic without physically accessing the machine. This guide provides a comprehensive tutorial on using Netconsole to debug Linux and proxmox kernel panics, covering everything from configuration to interpretation of the received logs. What is Netconsole? Netconsole is a built-in Linux kernel module that provides a simple and effective mechanism for sending kernel log messages to a remote system over UDP. It acts as a network-based virtual console. It operates at a very low level, utilizing the network drivers directly, making it robust even in scenarios where the file system or other higher-level services are unavailable, example during early boot or a kernel panic. Key advantages of using Netconsole *** remote debugging ** monitor kernel output from anywhere on the network, eliminating the need for physical access. * kernel panic recovery * capture crash dumps and valuable debugging information even when the system is in a critical state. * early boot debugging * monitor the boot process from the initial stages, identifying problems that might prevent the system from starting up. * lightweight and robust * operates directly on the network stack, minimizing dependencies and increasing reliability during critical failures. Easy setup * relatively simple to configure and use compared to more complex debugging tools. 2. Setting up the Netconsole server, receiver. First, you'll need a server to receive the logs sent by the target machine. This receiver can be any Linux system on your network, ideally one dedicated to logging. You'll need to install netcat, or NC, to capture the UDP packets. 1. Install netcat *** Debian/Ubuntu * sudo apt update and sudo apt install netcat traditional, or netcat openbst. *rhel/centos/fedora * sudo yum install nc or sudo dnf install nc. *arch linux * sudo pacman s netcat. We prefer netcat traditional as its behavior is more consistent across different Linux distributions. 2. Start netcat to listen for UDP packets ***. ***nc invokes the netcat utility. ***u specifies UDP transport. ***l enables listening mode. ***p6666 sets the listening port to 6666. You can choose any available port. This is the port you will configure on the client. *kernel.log redirects the received output to a file named kernel.log. You can specify any file name or path you desire. Explanation ***. This command tells netcat to listen on UDP port 6666 and save all received data to a file named kernel.log. This file will contain the kernel log messages sent by the client. Keep this terminal running. 3. Optional, time-stamping logs with ts and t ***. To make the log messages easier to analyze, it's often useful to add timestamps. You can achieve this by piping the output of netcat to the ts command, part of the more utils package, and then to t. *TS prep ends a timestamp to each line of input. *T sends the input to both the standard output, your terminal, and the specified file, kernel.log. 3. Configuring Netconsole on the client, target machine. Now, you need to configure Netconsole on the machine you want to monitor. There are several ways to configure it. We will discuss 3 primary approaches, using the kernel command line, using systemd networked, and a temporary runtime configuration. 1. Identify the network interface *. Determine the name of the network interface you want to use for Netconsole. This is crucial for configuring Netconsole correctly. You can use IP address or ifconfig to list the available interfaces. For example, look for an interface with an IP address assigned, example eth0, in 0s3, ans33. Note this interface name as you will need it in the next steps. 2. Configuration methods *. A kernel command line, persistent. This is the most common and recommended approach for persistent configuration. It ensures Netconsole is active even during early boot stages. Edit the bootloader configuration *. The exact file you need to edit depends on your bootloader. *grub, debian /ubuntu /proxmox /centos /fedora edit /etc /default /grub. Add or modify the grub _command line _linux line to include the Netconsole parameters. If the line does not exist, create it. Replace the placeholders with your actual values. *client _IP, the IP address of the client machine, the one you are debugging. *server _IP, the IP address of the server machine, the one running netcat. *interface, the name of the network interface you identified earlier, example eth0. Example *. If the client's IP is 192.168.1.10, the server's IP is 192.168.1.20, and the interface is eth0, the line should look like this. If there are already existing parameters on the grub _command line _linux line, append the Netconsole parameter. *systemd boot *edit /boot /loader /entries /yourentry.conf. Add the Netconsole parameter to the options line. The syntax is the same as above. Netconsole equals 6666 at client _IP /server _IP, interface. *lilo *edit /etc /lilo.conf. Find the image equals section corresponding to your kernel. Append the Netconsole parameter to the append equals line. Update the bootloader configuration *. After editing the configuration file, you need to update the bootloader to apply the changes. *grub systemd boot *. No specific command is needed to update systemd boot. The changes take effect on the next boot. *lilo reboot the client machine *. The changes will take effect after the reboot. *b systemd networked, persistent, alternative. This is a persistent configuration method that utilizes systemd networked. It's particularly useful when you're already managing your network configuration with systemd networked. Create a .network file create a network configuration file for the interface you want to use for Netconsole. The location of this file is typically /etc/systemd/network/. The file name should match the interface name. For example, if the interface is eth0, create a file named eth0.network. Add the Netconsole section *. Add the following section to the network configuration file. Explanation ***. Match specifies the interface that this configuration applies to. *name, the name of the network interface. Asterisk network, configures the network settings for the interface. The DHCP setting depends on whether you are using DHCP or a static IP address. Asterisk Netconsole, configures the Netconsole settings. Asterisk local port, the local UDP port used by Netconsole, must match what Netcat is listening on the server. Asterisk remote port, the remote UDP port used by Netconsole, must match what Netcat is listening on the server. Asterisk local IP, the IP address of the client machine. Asterisk remote IP, the IP address of the server machine. Asterisk enable and start systemed networked asterisk. Asterisk reboot the client machine asterisk the changes will take effect after the reboot. Asterisk see runtime configuration, temporary this method allows you to enable Netconsole temporarily without making persistent changes to the bootloader or network configuration. This is useful for testing or one-time debugging sessions. It requires that the network interface is already up and configured. Asterisk load the Netconsole module asterisk. Replace the placeholders with your actual values. Asterisk device, the network interface name, example eth0. Asterisk local underscore port, the local UDP port, example 6666. Asterisk local underscore IP, the IP address of the client machine. Asterisk remote underscore IP, the IP address of the server machine. Asterisk remote underscore port, the remote UDP port, example 6666. Example asterisk. Important note asterisk this configuration is not persistent. It will be lost after a reboot. 4. Testing the Netconsole setup. After configuring Netconsole, it's crucial to test if it's working correctly. Here's how. 1. Send a test message from the client asterisk. This command writes a message to /dev/kmsg, which is the kernel log buffer. Netconsole should capture this message and send it to the server. 2. Check the server's kernel.log file asterisk. If the setup is correct, you should see the Netconsole test message in the kernel.log file on the server. If you don't see the message, double-check your configuration and ensure that the client and server can communicate with each other over the network. Firewall rules can often block UDP traffic. Inducing a kernel panic, for testing. Warning asterisk inducing a kernel panic can cause data loss or system instability. Only perform this on a test system or virtual machine. Do not do this on a production system. To simulate a kernel panic and verify that Netconsole is capturing the crash dump, you can use the following command, again, only on a testing system. This command triggers a sysrq crash command, which intentionally crashes the kernel. The system will halt and output a kernel panic message. Netconsole should capture this panic message and send it to the server. 6. Troubleshooting common issues. Asterisk firewall blocking UDP traffic asterisk ensure that the firewall on both the client and server machines allows UDP traffic on the configured port, example 6666. Asterisk incorrect IP addresses asterisk double check that the IP addresses specified in the Netconsole configuration are correct and that the client and server are on the same network. Asterisk incorrect interface name asterisk verify that you are using the correct network interface name. Asterisk Netconsole module not loaded asterisk if using the runtime configuration method, make sure the Netconsole module is loaded. Asterisk routing issues asterisk ensure that the client machine has a route to the server machine. Asterisk duplicate IP addresses asterisk make sure that no other machine on the network has the same IP address as the client or the server. 7. Interpreting the kernel panic log. The kernel.log file captured by Netconsole will contain valuable information about the cause of the kernel panic. Here's a breakdown of what to look for. 1. Call stack. Backtrace. The call stack is a list of functions that were being executed at the time of the panic. It provides a trace of the code path that led to the crash. Look for function names that might indicate the source of the problem, example a driver name, a module name, or a specific system call. 2. Error messages. The kernel will often print error messages or warnings before the panic. These messages can provide clues about the nature of the problem. Pay close attention to any messages that mention specific files, devices, or memory addresses. 3. CPU registers. The values of the CPU registers at the time of the panic are also included in the log. These values can be helpful for advanced debugging, but they often require specialized knowledge of the kernel architecture. 4. Kernel version and build information. The log will also contain information about the kernel version and build configuration. This information can be useful for identifying known bugs or security vulnerabilities. 5. Oops message. If the kernel panic is caused by a dereference of a null pointer, or other memory error, there will often be a section called oops which contains the faulting address, register state, and the instruction causing the error. Example kernel panic log snippet, illustrative. In this example, kernel panic, not syncing, attempted to kill init. Exit code equals 0x00000000. This is the main error message indicating that the init process, the first process started by the kernel, was killed. Call trace, shows the functions that were called before the panic, including panic, do_exit, and kernel_init. This suggests that the init process was terminated during kernel initialization. CPU, 0 PID, 1 COM, system not tainted, provides information about the CPU, process ID, and command that was running when the panic occurred. Not tainted means no out-of-tree kernel modules were loaded. 8. Debugging proxmox kernel panics. The principles of using Netconsole for debugging proxmox kernel panics are the same as for general Linux systems. However, there are some proxmox-specific considerations. Proxmox uses grub. Proxmox uses grub as the bootloader. So follow the grub-related instructions in the kernel command line section to configure Netconsole. Make sure to update grub after making changes to /etc/default/grub. Network configuration. Ensure that the network interface you're using for Netconsole is properly configured in Proxmox. Proxmox typically uses bridged networking, so make sure the bridge interface is correctly configured and active. Firewall. Proxmox has a built-in firewall. Ensure that the firewall allows UDP traffic on the configured port, example 6666, between the Proxmox node and the Netconsole server. Use PVE firewall status and PVE firewall rules to check. Example Proxmox Netconsole configuration *. 1 edit /etc/default/grub *. Add the Netconsole parameter to the grub_command_line_Linux line. Replace Proxmox_IP with the IP address of the Proxmox node, server_IP with the IP address of the Netconsole server, and VMBR0 with the name of the bridge interface, usually VMBR0. 2. Update grub *. 3. Reboot the Proxmox node *. 9. Advanced Netconsole usage and considerations. Security. Netconsole sends data unencrypted over the network. Therefore, it's crucial to use it on a trusted network or implement additional security measures, such as a dedicated VLAN or IPsec tunnel, to protect the log messages. Performance Netconsole can introduce a small performance overhead, especially if the network is congested. Consider the impact on performance when using it in production environments. Filtering You can use kernel log levels to filter the messages sent by Netconsole. For example, you can configure Netconsole to only send panic messages. Combining with kdump Netconsole is often used in conjunction with kdump, a kernel crash dumping mechanism that saves a complete memory dump of the system at the time of the panic. This allows for more in-depth analysis of the crash. Netconsole helps to ensure you get some log data even if kdump fails. Proxmox has built-in support for kdump. Using with VMS Netconsole is particularly useful for debugging issues within virtual machines where direct access to the console can be cumbersome. You can configure Netconsole within the guest VM to send logs to a Netconsole server running on the Proxmox host or a separate machine. Conclusion: Netconsole is a powerful and versatile tool for debugging Linux and Proxmox kernel panics. By redirecting kernel log messages over the network, it enables you to capture critical information even when the system is in a critical state. By following the steps outlined in this guide, you can configure Netconsole effectively and gain valuable insights into the causes of kernel panics, helping you to diagnose and resolve problems quickly and efficiently. Remember to always test on a non-production system first, and to be mindful of the security implications of sending kernel logs over the network. Good luck debugging.